Hello, everyone, and welcome to Chapter 6, where we're going to be talking about the normal curve, standardization, and z-scores. So our first section of this chapter is really going to cover the normal curve. Now, I know we talked about the normal curve back in Chapter 2, but we're going to go into more detail here. So the main learning objective that we'll be targeting in this section is to calculate values using the z-score formula, which we will actually learn in section 6.2, and explain what it means in the context of a problem. And that's where we're going to wrap our heads around in this section for today. So we'll also be answering questions of what is a normal curve, why is it important, as well as what is a z-score and what does it represent. So first thing, this is a normal curve. It looks like a little bell, and a lot of variables are normally distributed. Now, if you will recall, when we're looking at a distribution that looks like this, on this axis here is our variable. And then on this axis here is the frequency, or how often people get a particular score. So most people get a score here, okay, for the normal distribution. Now, we see that variables like intelligence are normally distributed. Most people are in the middle, like with an intelligence score of about 100. And there are very few people who have really, really high intelligence up here in the distribution. And there are very, very few people who have really low intelligence on this side of the distribution. We also know that height is also normally distributed. It is separated by gender, though, because men and women have different average heights, right? Men tend to be taller on average. So there are two different sort of distributions for men and for women in terms of their height. However, I do want to point out that a lot of variables are not normally distributed. A really classic example of that is income. We know that income tends to be positively skewed. If you'll recall from a previous chapter where we talked about skew, a positive skew is where the tail is pointing to the positive end of the distribution. And so we see that most people have incomes around here, and the very lucky few people have very, very high incomes. So when we look at the normal distribution, why is it important for us, right? We use it in statistics a lot, and you're going to see that moving from here forward. One type of normal curve is a distribution called the z distribution, and that's what we're going to start our discussion with today. So in order to use that z distribution, we need to learn about z-scores. So what is a z-score? Well, a z-score basically tells you where a score is within the distribution. So there are two parts of a z-score. The first part is the sign, positive or negative. And that tells you whether your score is above the mean or below the mean. A positive z-score tells you that it is above the mean. A negative z-score tells you that it's below the mean. So what would the mean be? It would be 0 because it is equal to the mean. So the other part of a z-score is the actual number. We call that the magnitude of the z-score. And that tells you how many standard deviations away from the mean a score is. So that might be a little bit hard for you to grasp. So let's look at some examples. So I'm going to pop them all up on the screen, actually. And so I want you to think about what each of these represent. Okay, so for the ones where I give you a z-score, I want you to describe for me where in the distribution it is. And for the ones that actually do have a description, I want you to give me what the z-score is. So I'm going to give you a second to think about that. Okay, so let's look at all these z-scores first. So for a z-score of +2, the first part of it tells me that this score is above the mean. And the number tells me that it's 2 standard deviations above the mean. So above the mean by, excuse me, 2 standard deviations. All right, for my z-score of negative 0.25, that tells me that this is below the mean by 0.25 is a proportion. Excuse me. And that proportion is 1/4 of a standard deviation. So it's actually pretty close to the mean. And then this last one, z of -1, tells me that that is below the mean by 1 standard deviation. Now, the other thing that I want to point out here is that you can actually locate where it is if you draw a distribution. One of my favorite things is to draw. I think that it really helps us to visualize. So if I were to draw a normal curve here, this one is above the mean by 2 standard deviations. So this is 1 standard deviation. There's 2 standard deviations. So this z-score of +2 is right about there in this distribution. Let's draw this one. Okay. If this is 1 standard deviation, that would be half right there, and a quarter would be about here. So a z of -0.25 is right about there. And then this one down here, 1 standard deviation below the mean would be about here. So that's a -1 right there. So knowing the z-score can show you where it is located in the distribution. Now, for these that actually do have a description, I can also convert those into z-scores. So above the mean by 3 1/4 standard deviation. So above the mean would be positive, and then 3.25 would be 3 1/4 standard deviations above the mean. Below the mean would be negative, and 1 1/2 standard deviation. So that would be z of -1.5. And above the mean by half a standard deviation, my z-score would be +0.5. So I'm hoping that through this practice, you're starting to understand what this z-score represents and how it can help us to see where a score is within the distribution. All right. So what do you want to take away from this section? Well, you want to make sure that you are able to, if you are given a z-score, describe where it is in the normal distribution, and given a description of a location in a normal distribution, be able to identify the appropriate z-score. Big ideas here. Understand why the normal distribution is important and how the z-score or the z distribution is related to the normal distribution. A z distribution is a type of normal distribution. Not the only one, but it's one. All right, that's all I've got for you today. I will see you in the next video. Bye.